trigonometry word problems, angle of elevation and angle of depression. So I just want to give you an example of what each of those vocabulary words mean, and then we're going to do 3 quick examples. So angle of elevation is the idea that if you think of airplanes, we're just going to do this all in terms of airplanes. There's a runway that the airplane is going on, and then when it takes off up into the sky, here's my little airplane. Okay. When it takes off, this angle right there is the angle of elevation. How high or how quickly is, I guess how high is more accurate, how high is it rising? That's the angle of elevation. So you can see if we put, at, 20 seconds, it's 15 feet high. You can see we have a right triangle, and you can use trig to figure out different bits of information. So that's what the angle of elevation is. And then the other one is called the angle of depression. So that's more like the airplane is now landing. I know I'm a beautiful artist. So here's our runway it's going to land on, and it's going down this way. Now the interesting part is that the angle of depression is actually the difference between if the plane continued flying straight, parallel to the ground, and when it goes down. This is actually the angle of depression. However, a lot of the time people tend to put it here and do the problem that way. That's also the angle of depression. And we haven't done parallel lines and their properties yet, but these have a relationship. They're called alternate interior angles, and alternate interior angles are always congruent. So while the angle of depression is technically this angle here, it is the same as the angle between the ground and the line. Okay? So that's a quick overview of elevation and depression, and I'm going to do 3 problems from your orange workbook to give you an example. So the best part about these problems is you get to be an artist and draw some pictures. So Jada, here's Jada. She's standing 10 feet from the base of a tree. And spots a nest sitting on a branch. There's our bird's nest. So she's looking at the bird's nest. The angle of elevation from the ground where she is standing to the nest is 55 degrees. How tall, how high up is the nest? So do you see that right triangle kind of tucked in there, right here? All right, so now we need to decide, are we going to use the Pythagorean theorem? Well, no, because we know one side and we're looking for a side, but we don't know 2. So this is not a Pythagorean theorem problem. Are we going to use sine, cosine, or tangent? Well, from our angle, we have the opposite side and the adjacent side. We don't have the hypotenuse. So think for a second, which trig function has the opposite and adjacent sides? Yep, it's tangent. So we're going to do tangent of the angle, 55, equals opposite, x, over adjacent, 10. And in order to solve that, we need to multiply both sides by 10. So we have 10 times tangent of 55 equals x. And then you just type that in, 10 tangent 55. X is approximately 14.3 feet high. So that's kind of how angle of elevation works. Here's another one. The angle of elevation from the top of a 90-foot tall building, 95-foot tall building. So here's a building. And this building is 95 feet tall. To a hot air balloon in the sky is 76 degrees. If the horizontal distance between the building and the hot air balloon is 354, find the height of the hot air balloon. So you see the triangle there. And we're going to need to know this piece. How high up is that? So think about which trig function we're going to need to use for that. If you chose tangent, you are correct. So tangent of 76 equals x over 354. Multiply both sides by 354. And 354 times tangent 76 is approximately 1,419.8 feet. Is that the whole answer, though? Well, it asked what the height of the hot air balloon is. And we also know the building is another 95 feet. So we need to add 95 to that. So the actual height of the hot air balloon is 1,514.8 feet high. All right, one more. We're going to do number 13. A surfer is riding a 7-foot wave. I know this is not where surfers ride, but you get it, I hope. Okay, there's our surfer on the wave. The wave is 7 feet high. The angle of depression from the surfer to the shoreline, so here's the beach, and the angle of depression would be the difference between if he went straight across or if he went down. So there's 10. Okay. Again, alternate interior angles are congruent, and so we can put that down here. What we want to know is the distance from the surfer to the shoreline. Well, the shortest distance between 2 points is a straight line, so that's the actual distance at this moment. We're not looking for the horizontal distance because that's not the distance from him to the shore. So hopefully you can see our little right triangle there. Here's our angle. We have the opposite side and the hypotenuse. So we're going to do sine 10 equals opposite over hypotenuse. And we're going to multiply both sides by x. So x sine 10 equals 7, and divide by sine 10. So x is approximately 7 divided by sine 10, 40.3 feet away. All right, I hope that was enough to get you started. Please look back at the assignment so you know what to do next. Bye.